All right, next question refers to putting tension on wires and listening to the sounds that they make. So I'll ask you, what if we decrease the length of the wire? So here's the original, and we're just gonna move the pulleys closer together so we create like a before and an after. Same mass hanging from each side. Okay, but just a shorter vibrating effective length. What will happen to the frequency? Will it go up, down, or stay the same? If we use a shorter string, we should expect to see a higher frequency. There is a formula way of understanding that. Let's find the formula for a frequency of a string. So right here, this is a formula for frequency of a string. And let's see what factors impact that frequency. So according to this formula, if we were to lower the length of the string, that has the effect of increasing the frequency because the L is on bottom like a denominator. Okay, great. That answers that one. You could also think about just a guitar. Like, the whole purpose of the guitar is to hold down the string at a particular fret. Like, you pinch it. And you guys have played with these guitar-like instruments quite a bit now. You have a bridge at one end. You have a bridge at the other end. Normally, the string spans the whole distance from bridge to bridge. Okay, but the purpose of a guitar is to allow the user to pinch the string against what's called a fret. So basically, they put their finger touching the string in such a way that they're going to be able to shorten the string. So they push down, and now the string does this. And so the effective length is cut down dramatically. It used to be this long. Now the effective length is only between the fret and the other bridge. So obviously they've shortened the length, L. So L goes down. And then what happens is the frequency goes up. Okay? Let's see what else they ask. They say, what if we were to change the linear mass density while keeping all other factors the same? So an example of that would be on a guitar, you got different densities of strings, right? So let's look at a guitar real quick. So you can see in this picture of guitar, yeah, there's thicker strings and thinner ones. Some of them will have a lower pitch, even though they could all be around the same tension. Some of them have a higher pitch than others. So which one do you think has the higher frequencies here? Thin, yeah, the thin, that's what we've seen in our past, yeah, and that's what that lab was supposed to demonstrate. So, to answer the question, yeah, decreases the pitch, exactly. So we also need that one, decreasing the length increases the wire pitch, yeah. Let's see if there's any others. Oh, they ask about the mass. So the mass would be related to the tension in the system. So they're talking about this being the before, and then we'll do an after. And let's say after, they just add some mass to the system. There we go. So what do you think? Yeah, when you increase the tension, that should lead to higher frequency, and we can look at a formula explanation for why that is. The first mass will have a particular weight shown by the length of those arrows. Let's say, just for sake of argument, that it's a 1 kilogram mass on each side. then the weight of the thing would be given by mg in physics, which is going to be 9.8 newtons. If there's 9.8 newtons of weight, then there must be 9.8 newtons of tension as well. And that tension will carry through the whole string. It's actually not like double just because you have weights on both sides. Well, that's a common misconception. It's just going to be a force of tension of 9.8. But with this guy, since he's got 3 times as much mass, his weight is 3 times as big. And so his weight is actually 29.4. So the tension must be 29.4 in that string. Way higher, 3 times as much tension. Now let's look at the formula. Formula says your string is given by 1 over 2L times the square root of the force of tension divided by the linear mass density. Since the linear mass density stays the same and the length stays the same, then those things don't matter in this situation. What matters is that your force of tension went up. And because of that, your frequency is going to go up. Okay? Let's see. So we got to select this one, third one.